All right, so in this video, we're going to go through sample question 92 from the Society of Actuaries ExamP list of sample questions. The question reads, two insurers provide bids on an insurance policy to a large company. The bids must be between $2,000 and $2,200. The company decides to accept the lower bid if the two bids differ by 20 or more. Otherwise, the company will consider the other two bids further. Assume that the two bids are independent and both are uniformly distributed on the interval 2,000 to 2,200. Calculate the probability that the company considers the two bids further. Okay, so we want to find the probability the company considers the two bids further, and that happens when when the difference between the two bids is less than 20. So when we have a joint distribution like this, we are going to want to draw a picture. And especially when we have this uniform joint distribution, we're definitely going to want to draw a picture because it's going to help us not do any calculus, right? We're calculating a probability. And because we're dealing with uniform distributions, we can kind of make this a geometry problem if we wanted to. So let's say X is the bid from the first company and Y is the bid from the second. Okay, I have X here and Y here, zeros here. So the bid from company one, that's going to be somewhere between 2,000 and 2,200. Draw those dotted lines there. And company two, that's going to be somewhere between 2,000 and 2,200. So in here, in this box exists all the possible, combinations of bids that you could get from these two companies. Now, we're asked about the difference, the probability that the company will further consider two bids. So they consider two bids when the difference is less than 20. Okay, so when X minus Y is less than 20, or Y minus X is less than 20. So if these two situations hold, then we're going to consider a new bid. So let's actually graph those lines. I'm going to set these both equal to Y. So I have Y is less than X plus 20. And here, right, so I'm just going to group that. And here I have Y is greater than X minus 20. So Y is greater than X minus 20. Group that. Now, the things we're actually graphing, I'm going to use here and here. Right? And we're going to find those lines cut across about here and about here. All right, so I'm going to use some other colors to kind of more define the shape, right? Because we're now dealing with a geometry problem. And again, we're going to want to do this anytime we're dealing with joint uniform distributions. All right, we have an equal likelihood of ending up anywhere in this square. The probability of accepting a certain bid exists in between these two lines, which I'll draw out here and here. So all we need to do is find the area of this red section and divide by the area of the full square, right? Basic geometry. So how do we do that? First, let's obviously get the area of the full square. So we know the distance from here to here is 200. The distance from here to here is also 200. So I said square. This could have been a rectangle, right? But it is a square. So the area of the entire square is 200 squared. Now let's try to find the area of this red portion. This is an irregular shape. We don't know what, there's no real area formula for it. So what I could do is find the area of these two triangles and subtract them away from the area of the entire square. So it's going to be 200 squared minus, extend that out. Well, what's the area of this triangle? We're going to need to know this coordinate point here, this coordinate point here, in order to get these two distances. Well, what is the equation for this line? This line was the equation, use a different marker here, y equals x minus 20. This line here, y equals x plus 20. So I want to figure out, all right, what are these 2 points here and here? Plugging in y for 2000, I find this particular point to be at 2020. Which means the distance from here to here is 180. And then similarly, I can find the distance from here to here to also be 180, and the distance from here to here to also be 180, distance from here to here to also be 180. Right? I actually looked at this problem beforehand. So I know these distances are all 180. Right? You can easily find that by just plugging in the correct value into the equations for those lines. So now that we know that, what's the area formula for a triangle? 1/2 base times height. So we subtract 1/2 area, 1/2 length of the base, which is 180, times the height, which is also 180. And once again, subtract the area of the base, 1/2 times, I keep saying area of the base, 1/2 times the base, which is 180, times 180. And from there, I just put that into my calculator to see what the probability of landing in that shaded region is. Let's see, the good old TI-30, 200 squared minus 0.5 times 180 squared minus 0.5 times 180 squared over 200 squared. And that gives me 0.19. Which lines up with answer choice B. All right, so overall, not a difficult problem. Let me go over just kind of what we did. We were told, hey, this joint, distribution, this multivariate distribution, it's made up of two things that are both uniform. So that tells me, great, if I need to calculate a probability, I don't need to do calculus, I need to do geometry. Joint uniform distributions, do geometry, not calculus. Now from there, I created a diagram to represent both of these. So first, since both of them were identical, I was able to create this square, right? Lower limit, the lowest bid is 2,000, the highest possible bid is 2,200. Same for both. And after that, I was given some extra information, right? Whether or not some company considers the two bids further, right? Now, if you're in here, then you've considered the two bids further. If you're outside, but still in this square, then you would have accepted the lower bid. Okay, so it's understanding how to get the equation for each of these lines, right? The inequality that represents it and knowing where to shade in. And then geometry, calculate an area and divide. All right, if there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button and subscribe because that definitely helps me out. But other than that, good. Good luck, and thanks for watching.